Hello, hello. Yeah. This was supposed to be a session, okay, only on code. I was supposed to upload a separate video for LSTM as well as for the regular RNN model. But now what I do is I take it all together. It's going to be easier to understand. That's fine. Okay. So let's discuss about the project first. So what we're going to build today is basically a model that can predict the stock prices. All right. So what model architecture we are going to use. So we are going to use basically RNN, which helps in time series analysis. Okay. Apart from that, you can also do text. Okay, the next word in a sentence. Okay, text prediction. All right, all that. So that is what RNN is used for. Now we'll be doing basically a model to predict the stock price for Google. All right. अभी Google के बारे में होगा. Now we are taking the data from 2012 to 2016, okay, and we are training it to predict. And we also have a test set, data set. That is our test set for 2017. So that will be our, basically model evaluation. So, all right. So what we're going to do is build a model prediction for a model for predicting the stock prices of Google's. Okay. So now architecture. Right? What architecture we will. So if you all remember this, this was our uh, ANN, right? So we have two right, it's two right. Just give me a minute. Okay. Wait, let me get back to the screen. Okay, you all can see this. So if you all remember this, this is from ANNs, right? So like you all have an input layer over here. Okay, then you all have the first hidden layer, second hidden layer, third hidden layer, and then the output layer. All right. Uh, okay. So yeah, this is your basic ANN. Now what is RNN? So what happens here is if we squash this, okay, what I've done is I basically compressed it to get this. It's just this, like the you can see each one. So what happened was I had this entire thing, okay, this entire thing. What I did is I just squashed it. I made it into a single kind, you can say like a layer, not a, but it's not a layer. It's just that so that you'll understand. Okay, so I made it into this. Now, what RNN is? So it's this. Okay. So see, it was a normal ANN. I squashed it into a single kind of a layer. So what happens in RNN is you have this layer, okay, which is having like a feedback loop. So if I get this, so this is like a feedback loop. So what happens here is you have data being given input here, okay, to this layer. Then it will give some output. Now, in order to get the next output, since this is output, in order to get, where's my pen? Okay. So in order to get this is the first output, say H1. Okay, it gets processed, you get an output. Now this is being sent back to here. Okay, as the first state one, H1. Let's call it H1, the hidden state one. So what happens is it gets sent here along with the new input. Okay, so we give it a new input plus the first state, and now it uses this to predict the second state. Now again, the second state will be passed to the front along with the third input to generate the basically the third output state. So similarly, this goes on. Now it's not, just having a single, like this was our neural network, right? This entire thing was a neural network. We squashed it to basically, so this is our one neural network that is squashed. not squashed in the sense, I just squashed it. So the thing is, it's like this. It's there, right? The entire neural network. It's just held like this, okay, like this. So just to represent, show you all, I squashed it. So then you have this, okay. Now this is an entire one neural network. Now what will happen is you will have another neural network, okay. So now this was one. You have another neural network. Now what happens is these two are connected. Now similarly, you can have another one here, another one here. So similarly, it goes on. It depends, like just how we use add, like in ANN or CNN. We use add dense layer. So similarly, here you do add LSTM. Now I'll get back to LSTM. What that is. So similarly, you will add layers according like what you specify. So that many layers will be added and they will be connected. Okay, connected. So in a sense that once the you get an output, you can pass it back because what we are doing here is sequential data. So we are basically dealing with sequential data or time series analysis. So every new state depends on the previous state. Okay. So say suppose I have a sentence. Okay. The sentence is the clouds are in the dash. Now, in order to determine the next word, okay, the word present in the dash, we need the context of the previous parts of the sentence. All right. So the clouds are. So what we are talking about a cloud. So say suppose we have the sentence. Okay, given as an say a word the. Okay, let's start with each word. So say the was given. Okay, it basically gave an output of the first hidden state. So say suppose we had our first hidden state. So say so we have first our input is given. Okay, somewhere say this my finger is an input. It basically processed. It got its first hidden state. Now it passes it back to this. Okay, it passes it back to neural network. Now I give it the second word that is clouds. Okay, so it takes this hidden state which has the. So it takes the plus clouds. It will generate the second hidden state. Okay, so for second input we have the second hidden state. Now this gets passed to here. The clouds are. Okay, I give the third word that is are. Now again a new updated state. The clouds are. Now it is passed here. Now it comes back here. Okay, now I give an input. The clouds are in the. I'll just take in the together. Given in the as an input, we get an output. The clouds are in the. Again, it comes here in the dash. Now I need to predict the next word. So it will like give a percentage of the next word. So say the clouds are in the sky. Okay, the clouds are something. Okay, say sky is the like possible word, so it will have a higher probability. So our next word is going to be the sky. All right. So that's how neural network works. Okay, so it's recurrent neural network because it depends on the previous state. That's why recurrent. All right. So this is all about neural network. Now there exists a problem in the the architecture that I showed you. So say suppose we have multiple of these. Okay, they are connected. Okay, they are connected. Now what happens is when you have quite a longer sentence. Say suppose in this we had a paragraph to process. Okay, so what will happen is in such case the model might not learn. Now what do I mean by model might not learn? So there might be a case of vanishing gradient. Now what is vanishing gradient? So the thing is, say suppose there were like 50 steps, okay, time steps. Say suppose you are at the 50th, then you have to predict the 51. Now what may happen is, say at 1 or 2, the weights may be so small that the gradient over there is very minimal, and so the weights cannot be updated using the optimizer. Now I basically told you all about gradient and all right. So yeah, that was told. Now, okay, again I tell. So gradient is basically the derivative of the loss function with respect to the weights. Okay, it is calculated by using the chain rule. So if the weight is small, okay, you're applying chain rule. Say weight is 0.1. If you keep on multiplying 0.1, 0.1, 0.1, it will become very small. That means it will vanish, right? And now in order to update the weights, okay, in order to use the optimizer, you need to have some gradient because the gradient helps in deciding by how much by or by what means you should update the weight, by how much you should update the weight. But if gradient is zero, it has vanished. So then how will it update the weight? There's no way in which it can update. Just give me a minute. So that's the thing. So yeah, once you have understood the gradient, the vanishing gradient problem, we need to solve it, right? Now, how do we solve it? So the most famous method is using LSTM. So I had sent you all the research paper, right? That's what I done. So this is LSTM. So what happens here is, see, in LSTM, it's long short-term memory. That means the network remembers what was said before. So by default, the network knows what happened in timestamp 0, 1 and 2. Okay, in 1 and 2. Say, consider the same example. We are at 50th timestamp. Now, what is timestamp? Okay, before going forward, timestamp is basically like, you know, say if we have a sentence, so the 50th word is like the 50th timestamp. Okay, this is just for you to understand. Okay, in like technical terms, timestamp is like the process or the point at where we are at. Okay, in the training, if you all got it. But in simple words, say we have a paragraph. Okay, so the 50th word means like the 50th timestamp. Okay, so say we are at a 50th timestamp and we need to predict the 51. Okay, what is going to be the output over there. So we need the 50th one. But say the gradient or has minimized at timestamp 1 and 0. Okay, it cannot update the weight over there. Not timestamp 1 and 0, but just for you to understand. Okay, just consider it like that. Now the thing is the gradient has vanished over there with respect to the normal RNN architecture. Now, say suppose we have LSTM. What will happen in LSTM is it will remember. So over there, the thing is like it is not just simply weights. Okay. So I'll discuss the architecture now. So if you'll see here, uh, LSTM does have an internal structure that basically helps in predicting the state of the cell. Okay. So it has a particular, say, like a pipeline, okay, or a line that basically has the history stored. Okay, the important data is stored in this. Okay, so what happens is basically like the successive cells have an idea of what important events, okay, had happened in the previous cells. So in a paragraph, okay, say suppose we want to predict the 51st word, okay, in a paragraph, it has the main idea of what happened in the previous 50 words. So that's what happened in LSD. Okay, so the state is preserved. So I'll directly start with the architecture. So if you'll see this, okay, this is the LSTM ka the most basic architecture and the standard architecture. There are multiple variations of this, but this is the like the most basic. So what happens here? Okay, so I'll just refer to this, okay, so that you all can read it again. I'll tell you all in short what this is. So this is a neural network, okay. This is basically multiplication, addition, okay, pointwise operation. These arrows obviously you all can understand. Okay, so what happens first is basically you have a forget gate. So if you all see it will be somewhere here, okay, some forget gate. So what happens here is this is our state, right? The history. Say let's for now let's just say call this line. It stores the history. So now what this okay if you all see here, if you all see here this particular thing, right? It's here. So what this will do is it will basically decide how much of the history is gonna be passed over. So now we are talking here in a single neural network. Okay, let me come back to the screen. So I showed you all this, right? This one. So in this, right, we are talking about this only what is happening here. Okay, I showed like there are multiple of these, right? Here, then again here. There are many. For now, we'll just consider this one. Okay, so whatever I'm going to say now is inside this. Okay, so let's go back. I just keep falling. Anyways, okay. So yeah, where were we? Okay, so the forget gate. All right. So what happens here is it decides how much of the history is going to be passed over. So we have a sigmoid layer over here, and we have a multiplication operation. So say suppose okay, let's take an example of a sentence which has say suppose a gender. Okay, it is talking about the male. Okay, in the earlier history of that particular sentence. But now there is suddenly a new basically gender entered. Now they are talking about a female. Okay, now the gender has changed. So what it will do is it will forget it will basically have there's a function over here where that will forget the male part. So whatever context with respect to the male was going on, it is like the gender context, okay? The gender context will be forgotten and the female context will be introduced later. I'll tell about this. For now, what will be forgotten? This is only the forget gate. So what data will be forgotten? So here it is given. Okay, here it is. Forget gate clear. Okay, and also they have talked about the gender. Okay, so if you see, the next word based on all the okay, in such a problem, the cell state might include the gender of the present subject, so that the correct pronouns can be used. So the previous subject has been forgotten. Okay, so if we see a new subject, say suppose there's a new subject, we want to forget the gender of the old subject. Okay, so that's what I basically explained. Now let's go to the next part. So the next part is basically to introduce a new topic. So say suppose now the previous subject we need to forget it. So we have forgotten it. Now we want to introduce the gender of this new subject. So what so the that particular operation is performed by this section. So here you have a sigmoid layer, okay, and again an activation tanh. So if you all remember in the intro, I just mentioned I didn't go in depth of the tanh, but I did mention about the presence of a layer called tanh. Okay, not layer, presence of activation function called tanh. So here basically the new candidate okay gets a value. It's a vector, okay, and then this sigmoid function depends how much of this will be added here. So if you all see the sentence here, we multiply the old state. Okay, the old state is multiplied by ft. This is basically talking about this part. Okay, this particular section. Forgetting the things we decided to forget earlier. Then we add it into ct. Okay, this is a vector, and I is the value of the function. So this new candidate, okay, also this value ranges from 0 to 1 since this is sigmoid. Okay, so we specify how much of it. Okay, so yeah, the new candidate values are scaled. Okay, scaled by this particular value it and basically updated to this particular pipeline. Okay, now once this is done, this is basically explaining in depth. Like they'll tell you, you multiply, then you perform the addition operation. Okay, so yeah. Now apart from that, we have the last thing. So what happens here is it basically tells how much of this updated state will be outputted. Okay, so how much of this will be sent to the next particular neural network. So that's basically having again the sigmoid function, okay, multiplication operation, and then you apply 10h. 10h gives a value from -1 to 1 because 10h, right? If you all remember the graph. These are the basically the functions. Okay, I'm not explaining that. Then we have variations. So now, uh, in general, I tell you what is happening. We have a neural network. Okay, let's consider. Let's take this. We have a neural network. In this, some input came. Let's just open this up. Okay. So in this, say suppose we got an input. Okay, this is the input. Say suppose it was talking about a particular gender. Now, say in this okay, so sorry, not in. This was this line that I drew. It was the state, okay, the previous state. Okay, now I'm introducing the input. Okay, input says there's a new subject that has a different gender. So now what we'll do is from this input, we'll basically remove the older subject. Okay, the gender of the older subject. So we'll remove it. Okay, and add. Okay, so we'll just remove it for now. Okay, say this line. It is that first sigmoid layer. Okay, neural network layer that I applied. So it will remove that older subject. I given an input right now. Okay, the new input with the new subject and the new gender that will be added now. So say this line is basically adding. It can't be seen. Wait, let me. Now is it somewhat okay? So this was our input history line. Okay, the history ka pipeline. First we forgot the older subject, then we introduced the newer subject, and now how much of the newer subject is going to be passed? Okay, so this entire thing is LSTM. This is in simple words. In that basically the papers, okay, research paper, it is there in depth. You all can read it, and those who have read well and good. Or else if you all didn't, you all can read it now after this lecture. So yeah, that is all about LSTM. Okay, with nine, there's nothing much. It gets complicated with the other versions, but this is the most simplest version, and we are going to use this one. So yeah, that's LSTM. So what we do is, so you can see this line, right? This line goes on to this one. Okay, so ये line इधर जाएगा, then this one's line will go, it continues, and once it reaches at the end, it will go back here. Okay, so basically the timestamps. So that is how we preserve the history, all the important data. So that is how we solve the vanishing gradient ka problem. All right. So now, mm, okay. So what we'll do now? No, I'll directly go to the code. All right. So we'll start with the code, and after that, yeah, there's nothing much. So we'll do a wrap up with after finishing the code. Okay. So the first part is basically importing. This is standard at this point. You should know the various libraries and the various functions. Okay, then Google stock price train. Okay, this I'll add to the Google Drive. Also the code, you all can refer to it. Download this data set and upload it by going here. Okay, go here. Once this gets connected, then you'll get an upload option over here. So basically do that and upload this data. Okay, yeah, this one. So I'll share this all in the Google Drive. Refer to it. So import it. You all know, right? This is again standard pd.read_csv underscore csv. Now after that, okay. Now if you look at this data set, there are many columns. What we are going to basically follow is this column. Okay, open ka. So hmm, now how does this work? So what will happen is the our model, okay, while training, it will look at this file. Okay, and this is timestamp one. Okay, let's call it T1. From now, timestamp I'll call T. Okay, so we have T1. In T1, we have this value. Now it will basically output this value as the first state, as the first cell state. You can call it cell state, history. It just remember it is the previous state, previous output. Now this is passed again to the neural network. Okay, no, yeah, to the layer. Sorry, to the neural network as the input of the previous state, and a new input is given. Okay, now, okay, one more thing that might be confusing is when you pass this, right, you need to pass this again to get this one. Now once you pass this, okay, you have a history this in order to predict this. Again I'm saying, you give this as an input, you have this as the history, and you're predicting this. Or when you do it for the first time, this is the input, this is the history, and you predict this. You do this two times. First one, you'll get a state T1, timestamp 1. I'll call it the state as H1. Okay, so H1 is 325.25. That will be passed again, H1, 2 with a at the timestamp of 2. Okay, so T2, we have H1 as 325.25 to get basically the new output along with H2. So H2 is now 331.2 along with 325.25 to get H3, okay, as well as the third output, that is this 329.83. So we are using the previous output in order to get, means the previous history in order to get the next output. So if we want to predict this, we need a history of this. So what will happen is it will learn a pattern, okay, through this. So I'll show you one more example. So just give me a minute. I'll write something and then I'll explain. Okay. You all know the Fibonacci series, right? So I'll do that. So now if you see here, if it's okay, see what I've written is right. One, okay, one. Then I have one. So one plus one is two. Okay. Then two. One plus two is three. Then two. Okay. So two plus three is five. Now what will be the next one is five plus three. That is eight. Okay. So we'll get eight over here. Over here it will be eight. Okay. So what is happening is we need there's too much lighting. We need the previous two states in order to get the next state. Okay. So similarly it will go on. So the similar thing is happening here. We need a history of the previous state in order to predict the next state. That is recurrence. And that is why we are using recurrent neural networks. So that's the main idea behind neural networks. Okay. So yeah, that's how the basic model idea is. Now going back to the code. Okay. So what we're doing here, as I told you, we will only take the first column. What is the column number? 0, 1. Okay. So this is the first column number 1. So what we're doing is, so we want all the rows. Okay. Again, this is again explained in RNN. So data set or underscore train, I look basically locating, basically selecting the the column that you're interested in, or basically the section you're interested in. Here we want all the rows and only the first column. Okay. Now, why did I do one basis colon two? Why couldn't I just write one? The thing is, you could write one, but that will give you a 1D array. What we needed is a 2D array because for RNN particularly, it requires a 3D array. So in order to get a 3D, we need a 2D. So that is why I'll tell you how to get. We use reshape. I'll explain all that. But for now, we take the only the first the column number 1. That is the open column. Okay, we get values is to get those values. Now basically, I also explained scaling, okay, pre-processing in the RNN. I explained all the various pre-processing techniques, and one of them is mean max. So basically, okay, there are two major ways. Again, I'll tell you. One is normalization and one is standardization. Okay, normalization is basically getting into a range. Standardization is basically the value minus mean divided by what is that? The I don't know. Okay, while as normalization is the value minus min divided by max minus min. Oh, the standard deviation. Okay, for what is that? Not standardization. It's value minus mean divided by standard deviation. Cool. So what you're going to do is your normalization. Okay, basically in a range of 0 to 1. So mean max is a class. You use that class to give an input. Okay, you initiate that class using SC variable, then SC variable, and then you perform fit transform on the training data set. So now what happens is all these values, right? All the values over here. Now if you see it was 300, okay, 300, then you have 200. All this got transformed between range of 0 to 1. All right. So that's what happened here. Basically fit transform I explained. Okay, fit is calculations, transform is applying those calculated values. Now what you have is the input and the output. Now if you all see, unlike the previous sections, where we had like there were many columns given as the input and there was another column that was given an output. Here it's just one particular column because here you are doing time series. See here what is the output. Say suppose we are taking these values. So looking at these values, we are trying to predict what's the next value. Now looking at this values, we are trying to predict what's the next value. So here it is like we are trying to predict the next value based on the previous one. So time series analysis. This is basically called time series analysis. So here the output is the next stage and the input are the previous stages. Cool. So that's what RNN are. Okay. So yeah. So now X train and Y train will belong to the same column, but X train will be like the previous state and Y train will be the next state. Now, how do we do this? Now, you'll need to understand this problem, okay? This particular part. So for I in range 62, basically this is the last row number, okay? So what we are doing is we are taking a batch of 60, okay, or a group of 60, and we are predicting the next one. So we are looking at the 60 previous, basically, stock prices and trying to predict what will be the 61st one. Okay. Then what for the next step? Consider. Okay. So we have I in a range from 0 to 60, right? So we start with 60. We start with 60, right? So in this X train dot append, we have I minus 60 to 60. That means I minus 60 is 0, 0 to 59. because 60 I is 60, right? 60 is excluded. If you all remember, I said, right, the value to the right is excluded. Okay, you take one value smaller than that. So 0 to 59 is taken and added to x tree, and after that you add 60 as to the y tree. Okay, you will add here this 60th value. Okay, having the 60th row having a value to the y tree, and yeah, you'll add it there. And then after that, 60 to 61, so you'll get 1 to 60, and then 60th 61th value will be adding to y, whereas 1 to 60th value will adding to x. And after that again it will continue, so 2 to 61 will be added to x train again, and to y you will be adding the 62nd value. Okay, so this keeps on going. Then what you do in the, so till you reach the last, basically the last two. Okay, so once you do this, once you add, okay, all the values to x tree and all the values to y tree, you basically convert it into a numpy array, because that's how machine will accept it as an input, right? We need to convert it into a numpy array that we can give as an input for the model to train. Okay, we can't give this still. Okay, we still need to process it, we need to reshape it. Now if you see the next basically code line, it's about reshaping. So what we do is we give it x train. Okay, we give it x train. We give the number of, see, 0 is the row number. Okay, I think it should be the row number. Yeah, yeah, basically the same. So 0 represents the number of, oh sorry, the number of columns. X train represent the number of, oh sorry, 0 represents the number of rows. X train represents the number of columns. And here it's basically the number of features. Here we have just one feature, right? So we have only this one, only open. Say suppose you also wanted to include high. So in that case, we could, change it to 2 here. But in this case, we are just going to deal with one particular column. So we just have one. So by doing this, we have now a 2D array. Okay. अब हमारे पास we have a 2D array. Uh, so that's done. So we have reshaped. Again, there, okay, we have not done converting into 3D. Okay, that's great. You could also see why we have done this. Okay, I'll explain that. Where is it? Okay, here. So here हमने 2D कर लिया. Okay. The point of doing this is to make it a 3D array, because our RNN needs it's a time series analysis, right? Now, not always there will be only one factor that contributes towards giving an output for the stock price of the next day. Okay, say suppose today is the 50th day, today is the 28th day. Okay, it is not always necessary that only the stock prices of the past 27 days are considered. So there might be other cases. For example, Apple stock price, earlier, I don't know what it used to depend on Samsung's stock price, because Apple used to use parts of Samsung. So earlier, the stock price of Apple used to depend on Samsung. So that will be another factor that will decide. Okay, not just the stock prices of Apple based on the previous days. So in that case, we would have to have an additional value, a new value of 2 over. Okay, here since we are just using the previous, past stock prices, the stock price of the previous day in order to predict it for the next day. That's why we are just writing one. Otherwise, it will be a different value. Okay, so yeah, so we give them the shape of X tree. Okay, shape means the number of rows. Then we give the number of columns, since here it's just, okay, 1 represents the number of columns and 0 represents the number of rows. And then we have 1 representing the number of features. Cool. So after that, we go, so this is done, right? This thing of data pre-processing is done. So what we did is we had an entire data set for the stock prices from 2012 to 2016. What we did it was we basically made it into a 2D array. So we had 60 days, okay, 0 to 59, and the 68 day stock price. Then we had stock prices from 1 to 60th. Then we have 61st day car stock price. After that, it keeps on going. So the model will learn, okay, for based on the 60th days, it will look at the pattern. Okay, this was the stock price. Now it will look at the next, basically look at the output for the 61 day and the previous 60 days. What is the pattern that gave this stock price? Then it will go learning, okay, like that. So it will understand based on the previous states and it will give you all an output. Now that was basically pre-processing the data and also explained how it will happen. Okay, how the model will learn. Now it's building the architecture. So see, you start with sequential class. This is the standard step. You would define a sequential layer that is basically going to define sequence of layer. It's a blueprint. After that, you will add. Now we named it a regressor. Okay, just not necessary. You can name it regressor. You can name it anything. Just since we are doing regression, I named it regressor. Then to regressor, you will perform the add method. Okay, you are adding an LSTM layer. You all can go to the documentation for additional information about LSTM. Okay, so here we have LSTM. Then units. Units are 50. You can depends again as I explained in ANN, CNN. Up to you. You test here. 50 worked for me, so I'm using 50. Now return sequence. This parameter is basically right. Say in one neural network, second neural network. Um, I'm passing right. So this will return. Okay. Say suppose we reach at the end. Okay. Say suppose the sentence is now asking for an output. The clouds are in the now in the what? Now after this, should we return? Is the point in returning? क्योंकि ये मिल गया हमें, we got a refine. See the clouds first state, the first state, I explained right that the first state you get each one, then clouds, okay, second state, then again it will go. Now it reaches here in the now we need to predict the output. Now what will be the output? So in the sky that has a high probability. So basically we are saying at this stage you don't return. Now you give an output. So return will be set to false. Okay, since we don't need an output over here. Here we need basically we needed to return like once it reaches we need to return. यहाँ नहीं चाहिए हमें. So we will pass it. Okay, so return true means you will return. Okay, the state. Well is return false means you won't return. You just let it pass. So if you will see here, this is the first layer, right? This is the first layer. From here to here we have to pass. So यहाँ true करेंगे. We'll set it to true. So once you have this written, next is your input shape. Now since this is the first layer, we will have an input shape. Okay. Now if you see here, X train, we reshaped it, right? 3D matrix. So here what it will be, X train shape 1. So basically 2, comma 1, since there's just one feature, that's just one column. So we pass it as an input. So this takes as a 3D input. Okay, this LSTM expects a 3D input. You need to convert it into a 3D input. 2D input, 1D input won't work. So you need to convert it into 3D input. How do you convert it into a 3D input? By using reshape. Reshape, you pass the first parameter, then the data on which you need to perform the, basically adding a new dimension. Then you specify the first number of rows, number of columns, and then the number of features. Cool. Hope you all have understood that one. Now, okay, okay. Now, what is this dropout? Dropout is basically okay to allow fitting the model to the data. It shouldn't by heart the data. So, dropout means you're saying, just the say we have 50 neurons. So, dropout like when you are doing basically performing the training for an output. Okay, don't consider the first earliest like. Now say this was 50, right? So 0.2 means the 10. 20% of 50 is 10. So don't consider the 10 euro, the previous 10 euros. Okay, you all go forward with the 40 neurons. Cool. So based on that history, you all try to predict the output. So similarly, when it goes to next, it will ignore the last 10 neurons, and it will use the 40 neurons to predict the output. So this basically also it helps in more precisely avoiding vanishing rate. Okay, so just an improvement over LSTM to LSTM, not over LSTM. Improvement LSTM. So you once you drop out, then again, if you see here, we are adding a second layer. Again, the number of layers experimentation 1, 2, 3, 4, depends on. Cool. So we added the first layer. Now we are adding the second layer. Now if you see here, we don't specify the input shape because now from here to here it is getting passed. Right? It is being sent. So you don't need to specify the input here. Yeah, see input it will happen. So if you see sequential here is again true. We have 50 neurons here, 50 units here. Then after that drop out again here. 1, 2. Now copy paste. This also is same. Now if you see in the last layer, means the last LSTM, we don't have a return sequence. Okay. So we are here. We just pass. Bus pass. So once it gets passed, okay, then we have the output neuron. That is the dense layer. We just have one neuron. So once this is done, we say this is the output. Say this is the output. We just one neuron. So that is basically giving the output. Okay, now coming to, so this is the output. Okay, this is quite easy. The difficult part is understanding truly the RNN ka architecture, LSTM, how to improve, how to prevent vanishing gradient. Okay, that's the main part. Apart from that, it's almost similar to VNN, like compile. Again, here we are using Adam optimizer, and here we are using mean squared error since we are predicting stock prices. Right now, you can use mean squared error because it's not yes or no, it's stock prices. They have values, so they will differ. Here you can use mean squared error, again explained in the previous lectures. After that you fit it with X train and Y train. अभी train होगा 100 epoch batch size 32 explain. Okay, already done. So yeah, once the 100 epoch, then you have your test set evaluation phase. Okay, so yeah, so if you see in test set, again the same thing, all the rows. Okay, and we are just taking the first column open. Okay, I'll show you the test set. uh, so this is the stock prices for 2017. Also in what do you say, stock, like there are 20 days in a particular month, the stock price in no Saturdays. I Those who are in stocks, you already know that no Saturdays. So yeah, so we have 20. So if you see, we took 60, right? So it's like we're considering the past 3 months. Okay, we took 60 inputs, right? So see, if you see, this is 20. Okay, this is 20. So if we go to here, so there are like 5 years, 5 into 6, 12. So if you all calculate, here will be 12 into 20, 1,200. Okay, around that much. So that will be the total number of rows. So each 20 rows represents 1 month. Okay, so we are taking 60, right? If you go here at the start, in a range of 60, means we took this starting range. So for past 60 days, that means for the past 6 months, we'll analyze the data to predict what will be the cost on the fourth month ka first day. Okay, got it? So using the past 3 months ka data. So that's 60 days. Okay, just to clear it out. Okay, y'all can try with maybe 20 days, 10 days. Okay, works. I took 60. Y'all can maybe do it with different numbers and tell me, basically upload your models and your code with accuracy to Google Drive. I'll evaluate it. Okay, so yeah. So again, for evaluation, we take this, we do this. Then if you see here, concatenation. So okay, now here one more thing is, what you're doing is you're concatenating the data. So in order to predict, okay, the first day in 2017, okay, January ka first day, the stock price on it, we need 3 months ka pehle ka data, right? So in December, no, October, November, December of 2016. So we'll use that data, okay, in order to predict the value, the stock prices of Google on the first day of January 2017. Cool. So how do we do that? So first we'll add all the data, right? So we'll add from the test set, training set. That means from 2012 to 2016 plus 2017 ka data will add. After that, okay, also syntax wise, this is the test train set, that is 2012 to 2016. Then we have test set, that is 2017, and access means in a single column. Okay, add it in a single column. So add it like this in this column. So train का हो गया. Now below that you will add test card data. Cool. So that's how you'll get data total. Now after that we need inputs, right? So what we'll do is from data total, the length of this, right, data total. So here it is, let's go down. So 1215. Okay, so this minus length of test data set. So this uh, minus this 21 minus 60. Okay, minus 60. This will give us the data of October, November, December from 2016. Okay, so once we get these values, okay, that's the input. Then we reshape it again. Reshape. So 1D. So now this is 1D. Okay, this step here, this one is 1D. So we reshape it to 2D. Okay, and then here we again perform the transform basically on the inputs. So if I'll remember, we performed SC transform earlier, min max values. From 0 to 1, we brought it in a range of 0 to 1. Now those values, we are again performing the transform on this input, okay? Using the values which we used to perform transform there, using to perform transform here. So now we created X, uh, X test ka array. Now to that, see, again we do this range ka thing. How we'll do this? See, we are going from 60 to 80. Now why 60 to 80? This has how many values? 60 values. Now, so we start with 60 and we go to 80 because in a month there are 20 days. Okay. So if you want to plan, basically predict the day of the last month of January 2017, we need uske pehle ka 3. Okay. That is why from 60 to 80. Okay. Cause 60 of this input plus 80 of January 2017. Understood? Cool. So what we do is to X test to this variable, let's close this. To this variable, we append 1. That is, now see, 1 is, let's iterate value wise, okay, 60. So 60 minus 60 is 0. 260, 60 will be excluded, we'll consider only 59. Okay, so actual values are 0 to 59. And again, there's only one column, so there's no need to specify this, but 0. Okay, cool. So we are appending that to X test. Okay, append. Now the next one. The next one will be 61. So it will be from uh, 1 to 61. That is 60. So 1 to 60 will get appended. After that it will continue going. Okay. So ये होता रहेगा. So then we'll convert X test to a numpy array. Then X test will be reshaped again. How we basically did it over there. So reshape into a 3D array. Basically rows, columns, and then the number of features. Here is just the open feature that we are considering. So once we do that, we are going to create. Now this is also done again. A regressor, the class name dot predict. Predict means it will take this input data and it will predict the prices. So what we'll do is it will now take the first X ka column. Okay. So okay, let me just give me a minute. I'll open the PDF. Well, I was trying to find it. It's not there. I'll explain it using these papers. So this is one layer. Okay. 3D shape का बता रहा हूँ. One layer. This is another layer. Okay. So this is the one, two, third dimension. So this is how your recursive LSTM expects an input. So we have to convert it into this form. Okay, to give it an input. So what happens is, uh, say this is one feature, so it will take this and it will feed it. This is another feature. So it will take this and say suppose there were two features. So it will consider both of these in order to get the next particular outcome. So it will consider the previous both states. Okay. So that's how it will have worked. But since it's here it's just one, so I guess one works. So then we perform predict. Okay, it will take the input. So what it will do? It will take this line. Say suppose this is one input line. Okay, 0 to 60. Then this is 61. 0 to 59. Then this is 1 to 50, 60. 2 to 62. So what we do, it will take this and predict an output here. Now this one will be taken here. Okay, this state will be passed here. Okay. Now see, 0 to 59 60th ka ho gaya. Now it is 1 to 60. 60 state we didn't get it in the this no training data. We are in the initial input data. We got it from here. It got predicted. So now that state will be taken in order to predict the next state. Now here it is 3. We did 1 to 60. Here it is 2 to 61. Now 60 ka state we got from here. 61 ka state we got from here. And now we'll get 62. So that is how regression works. So it needs this one's value, this output to get this output. Okay. Not like ANN, yeah, RNN. You put any image and you will get, the particular output. It needs this to process the previous states. So the previous states are important. So that is how it will give you an output. Okay. One part that I forgot to mention. So yeah. Then after that, we perform inverse transform. See, we scaled it down, right? Now output we are not giving, we don't want to give the user the output as a value from 0 to 1. We want to give the actual value. So we will basically inverse transform. So whatever values were stored right in fit, we applied it to as transform. Now we will revert that process. Okay. So after reverting, we'll get an output. Now this is not important. This is just for you all to understand. So this is the code. I won't be explaining this, not important. You all can use ChatGPT to understand. So this is the real, okay. This is our like actual test set, this data, okay, this data, and this is what our model predicted. Now don't like you'll say, okay, this graph, don't like these lines don't overlap. Now the point of this model was not to predict the actual exact values, it was to predict the trend, okay, because also see we gave just one single column as the input parameter or the factor that decides the output. If we had multiple, then maybe it would have matched. Here it was just to detect like what was the trend, like is it going up or is it going down. So if you look here, like in the actual one it is going up. Here if you see, yes, it is going up. Now here it fell, here it went stable, okay, not that accurate. Now here it in actual one it went up and it dropped. Here also it went up, it dropped, but at a later stage. Now this is not that accurate. So now what is your work? Your work is to go and refine it. Again, I'll explain. I'll give a recap and then I'll wrap up. So what I want you all to do is go improve this model. Okay, change the neurons, change the layers. If you all want to delete a layer, delete it. If you all want to add it. If you all want to consider more than one values, for example, you took just the open right over here. We took. I'll go to the training one over here. Where is our okay? Over here, we just took this B. If you all want to take this one, take this one. Now, if you all want to take this, what changes you all will make? You all will go here. You all will change these values. Say, suppose you all want 1, 2, 2, 1 and 2. So, you'll take 1, 2, 3. So, that will give you 2. Then, after that, we keep make sure you are performing the fit transform on both. Then, when you are reshaping, right? Okay, here the range. Again, you all will need to make two values. Basically, add it normally. It will go. Then, while you're applying, okay, this array thing that's going to be remaining the same. Here, it is going to change. This value is going to be 2. Okay, rest again will remain same. So if you are adding that, just change it to 2. For if you are adding 3 more columns, change it to 3. Here in this, here also 2. Okay, just change it to 2. This is going to be, this is just the shape. It itself will state a shape. This one doesn't mean one, there is just one dimension. Okay, that one means it has a value. For example, here we use shape 0. Shape 0 means the number of rows. Shape 1 means the number of columns. Okay. After that, LSTM. Here you all can change this. You all can try. See, don't go too small. Don't go too large. Take some, just something in between. Okay. So yeah. So I'll explain. We have a recurrent. Recurrent is basically a chain of neural networks. So this is one neural network, other one. So they are connected. So they are chain. So then this one's output will be passed to this. This one might pass it back or it might give it as an output. Okay. So, and also at each particular neural network, we call it a timestamp. A timestamp in it. Now, what happens in neural network? So you get the basically the history of the cell state or the previous cell state. You get an input. So first, it will basically decide. what to delete from the cell state. Okay. Consider the same example. The gender of the old subject is needs to be deleted. So the first sigmoid layer will delete it. Basically, the input gate, sorry, the forget gate. After that, we have the input gate that will introduce the new subject, say the gender of the new subject. So that will input it. After that, we have basically the output gate that will decide how much of the new state is going to be output. Okay, so that what happens in a new in a particular basically cell of RNN yeah, or LSTM. Okay, LSTM here to be more specific. So that what will happen, and that will be passed, and then again revert if it needs to. So in order if it needs to go back, it will. And in that way, we basically get an output. So that was LSTM ka basic architecture. Now you can use multiple layers if you all want. You all can try out using multiple layers. Then you all can change the activation, or you can change the optimizer, the cost function. You can try it out. Apart from that, I don't think there is much. Return sequence also I explained. So if there's anything left, then I'll complete it during the next online lecture. This one I had to take offline. I was a bit busy, so yeah, I didn't get that much time. So, anyways, I hope you all have understood RNN. Okay, it's simple. Just LSTM का वो part you all have to understand. And what is RNN? Recurrent neural network. How it works? It is basically a chain of neural networks that are connected. Okay, and it stores the state. It has a memory cell. Difference between CNN, ANN, and RNN. CNN and ANN do not possess the past history, RNN does. And that is why it is called recurrent, because it depends on the previous history or the previous history. So yeah, cool. We are done. So that's all for today. I'll upload the data set as well. I'll give you some papers to go through. Okay, do go through that. Yeah, chalo, bye.